Hi, welcome to my channel, The Machine Learning Engineer. Today we have another video on the series Microsoft Artificial Intelligence and Machine Learning, while it could be as well in MLOps, but well, I just place it here because it's in the middle of the both topics. Today we are gonna see how to build a new MCP server. This time we are gonna build an streamable HTTP MCP server which connect to an database and provide access to the database, exposing a surface for different tools. Is on the line of other demos I did on the channel, where using in that time SSE. Usually I connect AI providers, LLMs in AI providers, to private data hosted in a SQL server. Could be Postgres, could be Microsoft SQL Server in this case, or we made videos about both, but usually in this kind of videos where I connect different technologies, agent technologies, or AI subscriptions, I use MSSQL server, and then I just modify the same MCP server to make it compatible with the authentication protocol, usually OAuth version 2, with the different flavors as sorry, every provider from OpenAI, Claude, or even now today that we are gonna integrate it with Copilot, had small differences which made that there is no a single solution that, even when MCP came to solve the problem of compatibility among different providers, still each provider is implementing a slightly difference in the in how they interact with the MCP server and how you define the connectors. And that's why from the initial one I did practically 1 year ago, when integrating an MCP server with the Claude AI subscription and the desktop. In that moment, we use an server, an MCP server which essentially implemented the SSE service servers sent event protocol, and with OAuth version 2 and self-registration from the server. To today, when we will see the streamable HTTP version, is when there was some changes on the way that, again, either Anthropic and the MCP protocol charter implemented and updated the protocol, and also how the different providers interpret the connections and how they I will say forced to use the protocol, the MCP protocol, with this type of authentication. Also saying that the SSE, the old SSE that we use up to now, had been deprecated. The server send events protocol is not gonna be used. Is not going to be used anymore on the MCP protocol, and they, I think, at the end of 2025 was fully deprecated. Still, you can use your connections, and along the 2026 it will not be usable anymore. So they promote to go into streamable HTTP, and the reason why is simply because well, SSC is considered legacy, is using two separate endpoints, one for post request from client to server and the other one from get request from server to clients. And this is a part of being more complex to manage. The sessions that we define in SSC is also more complex to maintain and spend 2 times more resources than Streamable HTTP. So at the end there was no reason to maintain the protocol, and we can do exactly the same with Streamable HTTP, and even combine bidirectional communications from client to server and vice versa, being asynchronous and even implementing streaming. So simply was a reason to optimize the connectivity or the transport protocol that the MCP protocol use when is deployed into distributed environments where you have the client and the server in different memory spaces and different servers. So again, today we will see how to create a server, how to connect it or create a custom connector in Copilot. We will test it, we will do some tests. We are not we will reuse the Nginx reverse proxy configuration to create a new location, and then we will check some interesting commands to debug the connectivity in between the server and and your Copilot infrastructure. Think that the same that we did in with other providers like OpenAI or Claude. Here we are connecting the Microsoft infrastructure where Copilot is hosted, the infrastructure that is running our Copilot agents, usually on the 365 ecosystem or the 365 infrastructure where we had our subscriptions. This can be located in different regions across the globe, and then we will have to connect this infrastructure in Microsoft to our MCP server. The MCP server similarly will be connected to a database. In this case, is a database that is running in a Azure environment, and the MCP server, this is just as a curiosity, is running in a virtual machine in Google Cloud. So we are connecting 3 different infrastructures. One is Copilot, the other one is the MCP server, which is running, as I said, in Google Cloud with the remote proxy, reverse proxy, and the database. The database which is running in a subscription in Microsoft Azure. And then you can see a little bit here the high-level architecture. We had here the client, our Copilot Studio, or the Power Platform agents. This is hosted in Microsoft. Via public internet, we connect to the reverse proxy. This machine is a project in Docker Compose with multiple containers. One of them is the Nginx reverse proxy, which is the entry point and for any requests, and then on is the point the IP address is also responding to the public IP address that where we have registered our domain. Remember that in order to connect OpenAI subscriptions or Claude AI or in this case Copilot, you need to have a public IP address. This means also you need to have a public domain, and this public IP address need to have a registered name in this domain, in this public domain, and we had to issue a certificate from an recognized certification authority to the domain where is hosted this public IP address. So this means that we will set that from the client infrastructure, in this case Microsoft, to our reverse proxy and SSL or TLS tunnel. And to do that and this work, we need to have this configuration. We are using a certificate from Let's Encrypt, and we use the Certbot container to automatically renew the certificate every 90 days. So before to continue, as I usually do, I introduce myself. I'm Juan. I'm an assistant engineer with more than 30 years of experience in the IT sector, and the past 10 years dedicated to this, to the AI and ML projects in different industries. Let's continue again from Microsoft to our infrastructure in Google Cloud. The entry point is our reverse proxy, which is responding into a public IP address. We had a public domain, registered public domain, a registered certificate issued by Let's Encrypt, and also a container which is not reflected here, but is another container in our Docker Compose project, which essentially verified every 12 hours if the Let's Encrypt certificate is still valid, and it is not valid, it is expired, it automatically renew the certificate. Just to remind you, let me show you a little bit. Let me see where I have the connections. Let's Encrypt org, and this is the certification authority we use to provide the certificate. Well known, as you can see, 700 million websites use this service. The certificates are free, so you don't need to pay a single dollar. And to renew the certificate, we use Certbot Certbot Let's Encrypt. This is a container which work in combination with Let's Encrypt, and we will see later in the Docker Compose. When we review the Docker Compose, it's just a container which use some services to automatically renew the certificate every 90 days. 90 days is the full-time expiration time. You can change this either to make it shorter or to make it longer. But they recommend 90 days. They are free. It's no cost as well in renewing the certification, so you can leave it like that. Okay. So the Streamable server, MCP server. So the connection to the backend is exactly the same. The only thing that we need to do is in the front. The connection to the back to the Microsoft SQL server is exactly the same. It's an ODBC connection. We use PY-ODBC to connect to the Microsoft SQL server. We have a read-only connection. In top of that, we had sanitization, so read-only SQL enforcement. This means that we sanitize the SQL queries, and we expose 4 different tools, the same that in other examples: list tables, describe table, execute SQL, and get table sample. So from the front, we need to implement, we did some changes in the MCP connection, mostly to change obviously from SSE to Streamable. There is some changes on the front which connect to the client, MCP client, which is in this case set up in Copilot infrastructure. There is some small changes that we will cover later on. And Here I just make a kind of comparison in between both protocols, the all HTTP plus server send events and Streamable HTTP. As you can see here, we have two connections here, this loop connection, which is essentially these two channels that need to be created constantly, one for sending requests from the client to the server, and the other one, this usually is a POS. When we use SSE from client to server, we use POS, and there is the response always a send. These two channels are created. You need to allocate resources when you initialize the server for every client which connect to your server. This means that you need to allocate two processes with two sockets to two channels in your network, which at the end of the day is much more complicated. Remember as well that the SSE connection had a caducity. There is an expiration time, usually 12 hours, 10 hours is a parameter. After that you need to renegotiate all the authentication, and on top of that, or beside that, at the beginning you need to implement the self-registration. This is not related to the transport protocol, it's how OAuth works, no? Once you are authenticated, or your client is authenticated, there is no change here. Doesn't matter if you use SSE or Streamable HTTP, the authentication is still the same. You need to use self-registration, you need to authenticate the client. This follow the same flow, but once we are authenticated, once the client is authenticated versus the server, instead to create a double bidirectional channel with two individual channels, we create a single one, and this one we use it asynchronously to send requests from client to server and send the response back from server to client. Okay, so now let's go to the details in the code. So first of all, let's go to the Docker Compose. The Docker Compose now it has different options here, as you can see. MCP server, I don't remember role. No, this is Copilot. Is that one. So we had a new entry in our Streamable HTTP. It's just similarly to the other implementations that we did, compatible with OpenAI Foundry. As you can see here, OpenAPI for actions in OpenAI. This is for Copilot Studio, but OpenAPI, OpenAPI. The difference with the OpenAPI that we use from OpenAI is that here is version 3.1, in Copilot use version 2.0, and then on here different versions of MCP servers. This is OAuth plus Streamable. Here we have another version for OpenAI. No, sorry, this is OpenAPI validated. This is another version. This is the one that works with OpenAI and in developed mode, and also with Cloud AI. And we had here, come on, demo. This is another story. Exactly, we had this is an SSE. This is compatible with OpenAI, and in developer mode and with Cloud AI is still using SSE. Here you can see the redirection. The redirection is used, we use it in our infrastructure to just allow requests from these domains in order to avoid that somebody can spoof or pretend to be somebody. So we will only send responses back to one of the domains are in this allowed redirect host, and as you see here in the new one that we are creating today, we are including the possible URLs that where the Copilot agents can be hosted. Copilot Microsoft.com, Power BI, Microsoft.com, agents, Microsoft, and also the other ones, because obviously we are in the server. We can remove potentially from here this stuff. No, Anthropic, OpenAI, etc. This is very important because this is the global authentication redirection URI, so this had to be as well included. This is something very particular from Copilot, and here, well, we can remove them. You can keep it or remove it, because as you can see, all this stuff is particular for every service that we have on the project in the Docker Compose. Apart of that, we have our ChatGPT, Copilot, OpenAPI. Come on, Copilot MCP, exactly. So it's exactly very similar to the rest. It's just practically copy paste. We have our Python 3.11 still. We just install a Debian. We install the driver PYODBC, and we install the requirements. The requirements are common for all the MCP containers, for all the Dockers or the containers that we have. Just simply we call a different script. In the script we use as the rest, we use Starlet as a instead of Fast API. We use Ubicon, the same, and pretty much the rest is the configuration of the environment, React only, the allowed or sanitization of the URLs, what is allowed, what is not allowed, the redirection URIs, helpers to verify the token is still valid, to extract the token from the header, and to verify if the redirection URI is one of the alloweds or not. The database utils, they are the different utilities to connect to the database. We have the configuration connection to the database. We have how to serialize the PYODBC, return the data in a specific format, and then on sometimes depending what we are asking, if you are asking to get a sample in order to flat all the objects that the database return, we use this mechanism, this method to just convert everything to text and return everything in a JSON RPC version 2.0 JSON RPC to back to the client. This is the method to list tables. It's just we are using the connection, and we are just simply selecting all the tables that we had on the database, describe table, similarly another connection, another query to the database. Here we have the procedure to check if the SQL that has produced the LLM is safe or not safe. we are blocking everything that can modify the database. And here, here we have the execute an arbitrary SQL. Here, first of all, we check if the SQL is safe, and secondly, we just make a query and we execute it. We execute the query here once we are sure that the connection is safe. If it is not safe, we return an error, and it is safe, we execute the query in our database, and then we serialize the raw data, etc. And finally, get table sample to get a number of rows, maximum 1000, just to avoid that you return thousands or millions even of rows. The maximum number of rows that we return back to the client is 1000. This is even too much. To do a simple, maybe 100 maximum should be enough. This is something that we may change because it's probably too much. Now we have the endpoints defined. The authorization server. This is the logic to implement our authorization server, which also allows self-registration. So this means remember that the clients running in the subscriptions need to have a server in our MCP server which allowed self-registration, because here the process is fully unplugged, so there is no manual interaction. Is everything happening under the hood. This means that the client and the server had to speak each other, and we had to allow the authorization server do self-registrations from obviously some clients. We are gonna check if these clients, we check it before the query get this endpoint. We will check if there is one of the domains that we allow to connect to this endpoint to do the self-registration. Here we had the protected resources to return which protected paths we have on the channel on the MCP server. So everything had to be particularly authenticated. So this means that the resource, the main resource, the endpoint that we are gonna use to set up the communication channel with the client need to have an authentication. And then on here your response, this is the response that we will send to the client to tell them here is the channel, this is the endpoint, and this is what is allowed in this endpoint. Here we had another method to register, and then on here you had to set up the redirect URI for this endpoint to call back MCP. This is something fixed, need to be done like that. This is to dynamic registration. And here authorization to authorize a client. This is to get the session token or the conversation token. And here we had this is the request, and this is the token that we will so first of all there is an authorization, and then there is a call to the token, and then we respond, or the MCP server respond with the token for a period of time. which in this case, as you can see here, expires usually in 1 hour. So we provide a token for 3600 seconds. Here some other helpers to initialize the Streamable HTTP error and initialize results. So here we had the catalog. When somebody call to make a call to the tool catalogs, we have list table, describe table, execute SQL, and get sample. We had here how to handle the calls. If the tool name is list table, this is when the model decides to use one of these tools. The MCP server is going to, well, if you tell me we expose this to this is what we expose to the LLM, the number of the tools that we had available, and this is when the MCP asks me to execute one of these tools. But it is the tool list table. I will execute list tables implit EMPL, here describe table, execute, and etc. Handled single requests, and then on here how the server respond to any method that is available on the MCP protocol. Initialize, modification initialize, tool list. Here we respond with the tool catalog, tools calls, here with handled tool, remember, handled tool and tool catalog. Here we have resource list with this, you have to implement it, but we don't have resources. We don't have here lists, and none of this, if you try to do something different to what is defined here, we return an error. That's why we create this other method here, make error, to return an error that this is not allowed. Finally, here we define the endpoints, the endpoint, the health check. This is not authenticated, and this is the routes for the authentication server and authentication resources. We are gonna go use these two entry points. This is the discovery entry points, where we discover where is the authorization server and which ones are the protected resources. This is how is usually implemented the OAuth Streamable or SSE. It doesn't really matter. Both of them use the same approach. The routes to authentication, register, authorization, and token endpoints. And then on here you have the methods. Remember, register, authorize. Let's check. We have it here. So it's gonna call one of the methods that we have here. Token, register, and authorize. Here routes, NC endpoints, go to definition is the one that we have here. What is allowed and what is not allowed, and how we manage every single method that is allowed. So here we have how we handle options, delete, get. Delete we say that is not allowed. Get is not supporting in this endpoint, and then on pause, if we get this point, so none of them are allowed, is only allowed pause. First of all, we extract the token, we validate if the token is valid, we check the header, we get the payload, we extract the request and the session, the ID, and finally here when everything is extracted, we simply handle the single request depending what we are doing, what is the method extracted, and depending on the method we invoke one of the methods that are defined here. Okay, so and then on the help point, so here is the MCPs. Well, here this you probably can make it simple, because well, at the end of the day we accept here these 4 methods, but we are only allowing to have we only implement posts. The middleware, everything by default, and then on we simply start the Ubicon application server with our application. Our application is a Starlet application with the routes on our middleware, and the port and the log level by default. So this is the server. Also we have configuration this is Copilot MCP. This is the server. A new location, you need to create a new location in here. This is you can see here that we have multiple location in our HTTP server. We have 2 HTTP, the 80, this is simply to use for the third bot. They had to have an open entry point in the port 80 for the certificate renewal, and the encrypted channel in the port 443. We had all the different locations, the header, so the root, Gemini components. This is another component. We have Open API actions, Azure AI Foundry, Copilot, Swagger 2.0. All these services have been explained in different videos, and here is the one for the Streamable MCP server. Copilot Health, well-known host, register, authorize, token, MCP, which is the protected resource, and then on how once something is hitting this entry point, once obviously we are authorized, registered, etc., is redirected to the MCP Streamable Copilot in the port 8013, and how we are redirecting or rewriting the headers that we receive from the client. If you remember, MCP Server Streamable Copilot in our Docker Compose is this service, which is at the end Dockerfile Copilot MCP, that one. And our Copilot MCP points to our Server Streamable Copilot, the one that we were reviewing here. Okay, this is from the side of the infrastructure. So this is the Nginx configuration, and now if we go to Copilot itself, so where is this? No, this is not that here. So in Copilot, so we create an agent, and once you have the agent, you connect a new tool, Model Context Protocol. You provide a server name, a server description, and a streamable endpoint. This is the URL that you use. In this case, it's gonna be where I have this is gonna be Docker Compose default account is gonna be Copilot MCP. So it's gonna be, in my case, the domain http data.com, and let me show you that one here. It will be /Copilot /MCP. Obviously, here is not we are not supporting get. You probably remember this from the code. We go here to our get. We are exactly seeing what the MCP server is telling us. We don't support get, and essentially is what we are responding. But well, this is the URL that you need to write down here. Then on here will be a post, and then on the authentication mechanism had to be OAuth 2.0. You can decide dynamic is the server is ready for that. Here you can use the dynamic discovery, simply dynamic. If you say dynamic, you where I have this, you need to put, let me show you here, the here authorization URL, which is essentially that one. You have this in the documentation. Is our authorized, our template, which is essentially the same. If you want to do this manual, you need to provide let me move this one here to follow authorization URL. You want to do this absolutely manual, you can do you can provide with this client ID. You can take this client ID and set up an authentication, a connection on the Power Platform, and well, I will show you how to create the secret right away. So if you want to create this manual, remember here in my case, this is domain, this is my location authorized, token URL template is gonna be the same. The refresh URL is gonna be the same. The scopes are gonna be MCP read, and now I will show you how to create the token. Copy this client ID that you have here, copy the name, in this case agent MCP server, and then this is everything in the documentation, so not worried. So here you can write something like that. Let me point out where I had information. So just simply write something like this, using a CURT to the Copilot register. Here's the domain, Copilot is the location register, header application JSON, a client name, which is MCP server, and a redirect URI, which is global consent Azure API and redirect. You send here, and then you get a client server and a client password. Note down these two, and then you go later you can return. Let me, you go here to the Power Automate in your Power Platform. You can create a custom connector. In the custom connector, let me show you, duplicate tab, and then we click in custom connectors. You create new connector, create it from blank, you get a name, and when you get a name, you get this point. You can put here a description, you can create a general information, you set that HTTPS data, this is the domain where you have hosted the Nginx server, the root, you go to security, here you choose OAuth version 2. Here you put the client that you received after the request. You create it here. You put the password here. Let's check this. We put the password also from here. This password. Well, my password is the client secret generated. Authorization URL, token URL, refresh URL, the scope MCP read, and when you update the connector, you get simply the redirect URL. You can copy here and paste it. Don't leave here, or it will be automatically generated. The same is the same that I'm doing here in the Power Automate. You can do it here. You can copy, click here the client ID, client ID, client secret, these are URLs, and let's do it here. You can create this and later, later. Okay, let's continue, but this will be exactly the same. Let me just, sometimes I have so many clients here. You copy the secret here, and the redirect Yuri is the one here. Obviously we need server name, MCP protocol to protocol server 2, and here we need to put where is our URL? Okay. Sure. Okay, so once you have here, you can essentially create as Okay, now you have it here, and then once you click create, you get this automatically populated. I'm not going to create this because I already had one. Leave. In any case, the same example is it should produce it like here. You go to security, you have your secret, we update the connector, we go to the definition. Close. Yeah. Description can be less than 30. Sorry, again. Sorry. Okay, security, custom connector descriptions can be less than 30. Definition, update connector. Okay, so now we can create here something to test. You can connect here, simply get a summary, a new action, description, a new operation ID, known. Here you just simply create from server. You can create you just paste here the URL, MCP Copilot, and the default response is a 200. And now you can go directly to test, and you can test the operation. One second. Yeah, sorry, I forgot to something here. Just define a name here, your description, an operation ID, and just simply you call the URL where you have the resource, the protected resource, and the response by default. Then you can go directly to test and test your operation, and you have here how this essentially works. Once you had your connection, you can go again, either you can define it here, or you can define it via here and then connect your HTTP protocol to that connectivity, to that connection. And then you can see here we have our server tool connected via this connection, and then you can just test list tables in the database, and yeah, you can see here that our MCP server is responding. We may do as well, probably, let me do here the sudo, maybe we had here, exactly. We can check the response here. So you can see here the HTTP, and now describe table for example, registration data, CSM, and then on here we got a post, and then on in our server, and now it's describing everything. And then on let's how many visitors we have in aggregated by, for example, batch type, and let's check what we are doing here. We call the MCP again via post, and just no, well, didn't work. It's just a aggregate, sorry, aggregate registration data by batch type. Let's check if this, oops, not this, not one. Exactly. In registrations, let me check it is generate another post, exactly. Exhibitor. Okay. So now we can deploy our Copilot. You can see here how it's interacting with the tools. And here we are using list table, describe table, execute SQL, SQL, and now a sample registration, sample get 3 records. And then on here, get table sample. And that's it, and then stop. Let's stop. I don't want you to see this stuff, but yeah, this is pretty much everything. You can see here, well, the agent is nothing particular. I didn't add knowledge. Default GPT 4.1, no knowledge, only tools, no agents connected here. No topics, new topics, no nothing. Everything is by default, and the only thing I create here especially was the connections to the MCP protocol. I remind you, here add tool, you go to new tools, modern context protocol, and from then everything I have explained you. Okay, that's pretty much all. Thank you very much for watching the video up to this point. I hope that you find it interesting, useful. I have, as usual, a lot of stuff opened. I hope that you find it useful for your job, for your training, for whatever reason are you watching this video. And if so, give me a like, subscribe to the channel if you are not already subscribed. Consider becoming a paid member of the channel. This way you have the option to get the code, the full code, especially for what I name projects. Projects are end-to-end components like here, and full MCP server with a streamable HTTP, which is able to connect to a Copilot agent. So you had access to the full code, to even to the configuration of the Nginx, and then on, well, I suppose that you can reuse practically many things of here, but obviously you will have your own configuration with your own certificate, etc., etc. If you need some as well some clarifications, you can contact me as well on via comments on the video, and I used to answer the as soon as I can, especially if you are a member of the channel. I try to answer you as soon as possible. Also, you can help me to follow to continue with this project, sharing this content with your friends and colleagues, and also making comments, give me a like, and this way the protocol or the algorithm in YouTube to scale up this content in and is seen by other users in YouTube. Thank you very much, and see you in the next video.